Good day, guys. All right, so in this video, I want to talk about velocity and acceleration. More specifically, I would like to split your understanding of velocity into two. Number one, it is the instantaneous velocity, and number two is the average velocity. So same thing with acceleration, we have instantaneous acceleration and the average acceleration. So let's look at the idea of instantaneous first. So when we talk about instantaneous of any physical quantity, we are talking about the value of that physical quantity at that moment. Okay, it is the instant value. So when we talk about instant velocity, right, we are talking about the velocity at that particular time. So say that time is t naught, right? So that's going to be dx over dt. All right, and then same thing with acceleration. When we talk about instantaneous acceleration, we are talking about acceleration at that particular time. All right, so dv over dt. Okay, now the difference between instantaneous and average is going to be you will have an easy way to see it when it's presented in a graphical manner. So let's have x against t, right? And then I have some graph. Okay, and then I want to know what is the value, what is the instantaneous value at, let's say, t naught. So t naught, all right? So it's that particular point, right? So now what we need to do is to find the gradient, right? The gradient at that particular point. Okay, now for the average, okay, for the average values of those physical quantities, what we are looking for is VAV. It is the range, or at least the value of velocity over an interval. So that what interval means is that it's going to be your final displacement minus your initial displacement over your final time and your initial time, and that you can sum it up. Yeah, you can simplify it into delta x over delta t. So same thing with average acceleration. You will have the final velocity minus the initial velocity over the final time minus initial time. So that is f. Okay, so that is delta v over delta t. Again, it's over an interval, right? So if we draw out the graph, what we will find is, instead of having one point like the case for instantaneous, you will have 2 points. So let's say we have 2 points here and here, right? So I have TF here, TI here, and the difference between them is delta T. And then I have XF here and XI here, and the difference between them is delta X. So as you can see, there are 2 points in the average case, and then there is only one point in the instantaneous case. All right, so moving on, let's look at the idea of uniform velocity. So when we say about uniform velocity or uniform, a physical quantity that's uniform, it means that, so let's call this physical quantity to be k, right? So if k is uniform, right, then your kf minus ki is 0. So what that means is that your kf is equals to your ki. So when we say uniform velocity, it implicates that our velocity, our final velocity, will be the same as our initial velocity. Okay, so what that means is that your delta v will be 0. What that means again is that your average velocity will be 0. Okay, so same thing that you can do with acceleration. And when we say uniform acceleration, right, what the implication is that your final acceleration will be the same as your initial acceleration. So what that means is that your delta A is 0. Okay, Okay, so next. The next thing that I need to tell you, or at least you need to know, is graphical representation for any motion. What I mean by that is you mainly ask two things. When we talk about graph, we always talk about two things. Number one is the gradient. What does the gradient represent? And the second one is what does the area under the graph represent? Okay, so let's look at the one example, right? So let's look at some example. I'm gonna draw a straight line, doesn't really matter. And then what I will do is I will write down some points. So here, the first one, and I have the second one here. All right, so when we talk about so I'm going to call this A, I'm going to call this T. A here is just some random variable, and I have AF here, and then AI here, TF here, and TI here. Okay, so when we talk about gradient, right, gradient, we'll be taking the difference between AF and AI and TF minus TI. So what we can see is that delta A over delta T, right? So what that means is that when we talk about gradient, it is the y variable, so y variable being A, over divided by the x variable, right? Okay, so gradient is about division, okay? And then the second part is the area under the graph, right? Area under the graph. So we can calculate the area under the graph fairly quickly from here by splitting them up into two, right? So it is in essence, okay, I have so area under the graph in this case is AI times TF minus TI, so it gives us the square, plus half AF minus AI multiplied with TF minus TI. Oops. Okay, so as you can see, for area under the graph, it is about multiplication. Okay, it's about multiplication. So these two ideas are very important: division and multiplication. Okay, so because it relates back to how you define those three variables, which are velocity, acceleration, and displacement. Okay, so let's look at the displacement time graph first. All right, so displacement time graph. Okay, so say we have some value. Okay, so again we ask ourselves, what is its gradient, what is the gradient, and then what is the area under the graph, what do they represent? So the gradient will be delta x over delta t, which is velocity. So here we can say the gradient under the graph, the gradient of the graph, sorry, the gradient of the graph represents velocity. The area under the graph is in essence, okay, a multiplied by t. Sorry, not a, x multiplied by t. Okay, so again, this does not represent any of the three. It doesn't represent x, it does not represent v, and it does not represent a, right? So in our syllabus, the area under the xt graph does not represent anything, anything. Okay, so next, let's look at VT graph. So VT graph. Okay, again, I have a straight line. The gradient, right, will be V over T, right, or delta V over delta T, fine. And this is actually acceleration. Okay, so the gradient of the VT graph represents the acceleration. On the other hand, the area under the graph, under the VT graph, is V times T. And that, sorry, so V times T. And that is actually displacement. So again, let's just remind ourselves, summarize that, okay, the gradient of the VT graph represents acceleration, and the area under the VT graph represents displacement, and that's how you answer the questions. Okay, and then last but not least, A against T, again I can have something like that, and I will have the gradient, right, is delta A over delta T, and this does not represent anything, so does not represent anything that we know in our syllabus, that is, okay, in our syllabus. The area under the graph, on the other hand, is A times T, which is velocity. So the area under the AT graph represents velocity. Okay, so that is all for this particular subtopic. Thank you.